So this is Math 1127, Probability and Stat, Session 3.4. The name of the session is Additional Topic, but really it's combination, permutation, and content method. So the question is, what are the difference between those guys, right? So first, let me talk about combination versus permutation. The key difference is the order doesn't matter in a combination. So there are two different ways to kind of count how many different choices you get when you combine different elements. So here is an example you can think about. All right, so combination, order doesn't matter. So it's kind of like think about if you go through like a drive-through, right? You go to the drive-through at McDonald's and you order like a Happy Meal or something like that, or whatever meal you order. Does it matter if they give you drinks before they give you food, or give you fries before they give you the sandwich? Not really. Order doesn't matter. When the order doesn't matter, then it's a combination problem. So one example would be, say you have, let's just say you have to pick three students from a team or from a class of 10 to be in your team. How about this? How many different ways can you pick your team, right? So it doesn't matter which order you pick. They're just going to be in your team anyway. So since the order of choosing your teammate do not matter, that does not matter, we will use combination method. For combination, this is something that we use. We will call NCR. What's NCR? N is the total number of elements. R is the number of choices that you're making. So in our case, right, in this example, N equals 10, because we got 10 people altogether. And R equals 3, because we got 3 people to choose from. So this is a 10C 10. Let me see if I can make it into an equation like that. Let me see. So basically, I want like a subscript. I wonder if I can do that. Like a subscript here. Yeah, not sure if I can do a subscript here. Be nice if I can. Maybe not. Let me see. Yeah, but it's of course a lot easier to write it out, but try to get it on. Oh well. I mean, doesn't matter anyway. So we'll just do 10 here. Oh, you know what? What if I do this? Never mind. So it'll be 10C. This is gonna look ugly. So let's just do like this. 10C3. Basically, we have an element of 10 people, right? And you choose in 3. Now, I can go through the formula, which is, I can type it out if you want to. Basically, the formula is gonna be this. NCR equals this guy. Let's do a fraction. N factorial. The explanation mark means factorial, and I'll explain. And the bottom is N minus R factorial. With this. So you're like, what is this thing? Factorial simply means, so if I have five factorial, right, that just means 5 times 4 times 3 times 2 times 1. And in this case would be let me say 20 times so that would be 120. So if you use this formula, you're supposed to get, insert equation, 10 factorial over 3 factorial, and then 10 minus 3 factorial, like this. And then you're supposed to get, 10 factorial, let me see, 3 factorial, and then times 7 factorial. You're supposed to get that, but here's the thing: don't worry too much about this, right? I know some of you guys might be crying right now about this, but in this class we are trying to work smarter and not harder. So you can put this on a calculator and get the answer, right? I can do on the calculator 10, right, on the TI-83, 10, and you might have to use some of the other tools that I showed you before. If you don't have a TI-83, you go to let me see, math, probability, right? See this number 4 right here, 10 factorial divided by the denominator. You're going to use supremacy, so it'll be 3 factorial, and then times 7 factorial. Now, of course, some of you guys already seen it where, okay, that's 120, that's great, but you do realize you saw something at the calculator that can really help us. You don't have to do this. You can just go through this here. Go to, so press, here's what I would do. Press 10. Now, if you have a TI-84, like a more fancy calculator, like a newer version, you don't even have to press 10 first. So for me, I have to. You just go to math, go to PRB, that's probability. You see NCR and NPR, those are the two that you're going to use. So NCR, right? Now for those, again, if you have a fancier calculator, when you press NCR, you can immediately put in the number, right? You don't have to worry about this 10. You don't have to put 10 ahead of time. You will see. So 10 NCR, what's the other? 3. So press 3, enter, 120. It's that easy. I like this one, right? This is nice. So that, and then you can use that to do the other problems where. So now if you have a permutation problem, right? So example. So let's just say you have to say you wish to pick, say 4 let's just say 4 let me say, oh, you know what, how about this, in a race with 8 runners, how many ways can we award the winner, runner, the runner up, and second runner up? Right, so gold, silver, bronze. How many different ways can we award those for the runners who take part in this race? So in this case, right, because order matters now. I mean, if you're winning, you don't want to be the runner up, right? I mean, I cannot be giving the gold medal to the third place. Because the order matters now, we have to use permutation. So this is a 10p, oh, I'm sorry, 8p 3 problem, right? Because the total is 8, right? So put in the calculator, right? I'll have 8 math and PR, and then 3, enter. So there are 336 different ways. It's that easy. Basically, you just use these two. So now, let me try to use that to solve some of our homework problems there. This one I was like, you know, express the result. I mean, come on, just use this, right? And say, I mean, they want you to solve it, but I wouldn't worry about it. You know, that, let me do. I think they just need you to do. Or I need to 57, right? Math, NPL 2. So that's 3192. So that's all they want. So this is the same thing. We'll just use a calculator. And let me say, now this one look a little bit crazy. You just gotta make sure that you do it twice. So do 7, right? Math 3, right? And then do 13. So there'll be 35 over 286. And you can just put in the calculator. 35 divided by 286. And I have 0.1224, right? Oh, to 1,000s. My bad, my bad. So that'll be 122. 3 decimal places. Right? So pretty easy if you know. Same thing, just use a calculator. So now, the number of ways 16 people can line up in a row. So how many times? So think about, right? Example, that's 3.4 to 0.15. Number of ways 16 people can line up in a row for concert ticket. So the idea is you got 16 people. Right, so the total is 16. Right, so the total, which is n, equals 16. And how many choices do you get? I'm choosing all of them. R equals 16. Right, I want to pick 16 people and line up. How many ways can I line them up differently? Does the order matter? Order matters in this case because we're looking at how many different ways they can line up, right? So this is a permutation problem. So it's 16p16. Right, just put in the calculator. So that'll be 16 math permutation 16. And I know it looks crazy right here with the E13. That just means move to the right 13 times. But it looks like they don't even need you to do that. Permutation, the order of 16 in the line matters. Right? So let me just enter that. But that's how you would solve the problem. The number of ways a 4-member committee can be chosen. So committee, you're talking about different position now, right? They should be a little bit more specific, like because you know if you go to the House of Representative or the Senate, a committee you can have peers, right? You know, equal ranking, but the committee they are talking about is like a president, vice president, secretary, speaker, whatever. So that's just honestly, you know what? I think it's a combination now. Now that I thought about it, because they didn't specific. Because committee can be peers and can be rank. Since they didn't say, we just assume there's a committee of just 4 people. So there you go. It all depends on what kind of committee we have. So it could be committee of public safety, and that is all ranked. So you might need to Google that if you want to figure out what I'm talking about. So 6 different video games. How many different ways can you arrange the games side by side? Does the order matter? Absolutely, because you have to arrange those games, right? At different, so there will be 6p6. So let's try it. 6 games. You're picking all 6, just in different orders. 6p6, and there's 720 different ways you can line them up. Outside of home, there are 5 key keypad with the letter A, B, C, D, E that can be used to open a garage. How each key can only be used one time. So how many codes can you make? Now this one you can actually think about in this matter. And this is what we call a counting method. So you have 5 keys, right? Each can only be used once. And you want to make a 5-letter code using those 5 keys. How many different ways can you do it, right? How many different ways can you create a code? Well, here's the thing. When I pick the first code, the very first code, the very first letter, how many choices do I have? I have 5 choices. But once I pick the first guy, on the second key, how many keys do I have left? 4 choices. Then 3 choices. Then 2 choices. This is called counting method. You just count how many ways can you choose as you multiply. And that's equal to 120. So the number in different ways is 120. So let's look at this one here. This guy can burn 12 songs. They got, the CD can contain 12. I don't know, you guys don't know anything about CDs anyway, But if you're old enough like me, then you know a CD usually have about 10 to 12 songs. How many ways can you arrange those 12 songs on a CD if you're going to burn it onto it? Well, that is a permutation problem because there are 12 songs, right? You want to put them, how many different orders, how many different ways can you put them? Order matters, right? So there will be 12. Permutation, right? 12. So it's a lot of ways. Just like that. There are 46 runners in a race. How many can finish first, second, and third? So there'll be 46, right? Math. And there'll be permutation again, the order matters. And there are 3 choices, right? First, second, and third, right? So there are 91,080. Right. So not too much. It's the same problem over and over, right? 16 finalists, top 5 receive a prize. How many ways can the singers finish first through fifth? So it's rank. Those positions are rank out of 16. So there'll be 16p 5. But you can try it out. 27 members. If you must select a chairperson, vice chairperson, notice those positions are all rank. So again, you're picking 4 positions out of 27 people. So that's 27p 4. It's a permutation problem. So how many different samples of size 5 can be obtained from 44 people? Now, that's the order matter. So let's say you got 44 people in your neighborhood. You're going to randomly pick 5 people to see what the incomes are, or age, or whatever you want to pick. If you're just collecting information, on their income, it doesn't matter in what order you pick those 5, as long as you pick those 5. So order does not matter in this case. This is a combination problem. So it should be 44, 44, math, right? Combination 5. And that's that. So you just got to think about every time, does the order matter? 26 students, how many ways can you pick 4? Order doesn't matter, right? You're picking people in the same group. So combination problem. Lottery has 28 numbers. How many ways can 4 of those numbers be selected? Order doesn't matter, right? If you're playing Powerball, right, you can pick 5 before you pick 17. Doesn't matter. So that's a combination problem. So yeah, it's not too bad as long as you know how to use a calculator. Please don't try to calculate by hand because this is not going to work. Just use a calculator or some sort of technology you have, right? But that will be the end of session 3.4 and really the end before the midterm, right? The midterm exam. So make sure you do the review. Make sure you check all the homework. Ask me any question, right? If you do the midterm review and you have questions you don't know about, you don't understand, let me know. I can work it out with you. I can make a video on that. But anyway, thank you for your attention and I will see you back in the next chapter.